Welcome back. This is the second lesson recording for IM2, November 5th, 2020. So you've just finished number 5 to number 9 cards for Desmos, where you've used the similar triangles to find the unknown length. So when you had these two triangles that are similar and you know the ratio of one triangle having the hypotenuse of 10 and then the longer leg is going to have the side length of 7.66 and the shorter leg having 6.43 as the length, then you can figure out what this is. How did you do that? Well, I know that the ratio between the ratio within has to be the same. So 7 over 7.66 divided by 10 or 10 divided by 7.66 has to be same as 20 over x. So for the right triangle with 50 degrees angle, the ratio of the opposite leg to the hypotenuse will always be the same. Specifically, if it is 7.66 divided by 10 is going to be, or 0.766 is the actual number. Okay, so using the side ratio directly. Okay, so instead of going back to the triangle, we can just figure out the ratio between the longer leg to hypotenuse is 0.766. So we use the side ratio directly when solving the side of similar right triangles. So instead of doing this, setting up as a ratio, we know that the ratio of the opposite side to the hypotenuse is 0.7666 for 50 degrees angle. So then m over 18 has to be 0.766, and so m has to be 13.788. All right, so then if we know this case, the ratio between p over 21 is going to be 0.766. So we set that up. So p has to be 21 times 0.766. So p is 16.086. So if we know the ratio for a given angle, then we can use similarity triangles to figure out the length of any 50 degrees triangles. Okay, what about this one? Okay, so what if we have 20-degree triangle? Well, we don't know the side ratio, so we can't solve for x, at least not yet, unless you have the pre-measured triangle. So if I give you all of this, then you know that the ratio between the opposite side, 3.42, to the hypotenuse is going to be 0.342, okay? Or if you have a 30-degree triangle, the ratio of the opposite side to hypotenuse is going to be 5 divided by 10, so that's going to be half, and so on and so forth. So having the pre-measured triangles, the ratios already given to us, that is helpful, because then we don't have to measure it ourselves. Because we are going to be using, the triangles are going to be similar, because you have the angle and the right angle, you have two angles of congruence, two pairs of angles of congruence. That means by angle similarity, you can use the ratio to be the same. So let's go specifically to the sine of theta. Okay, so sine of theta is the ratio of the opposite leg to the hypotenuse of the reference angle theta. So we read this as sine of theta. So this is the theta, angle theta of this. Then the opposite, the leg that is opposite to this is this side. Okay, it's across from. The hypotenuse is hypotenuse. Hypotenuse is always the side opposite the right angle. Okay, so it's always going to be sine of theta is going to be the ratio of the opposite leg divided by the hypotenuse length. What about cosine of theta? We read this as cosine of theta. We write it as cos theta, but we read it as cosine of theta because that's what it is short for. cosine of theta is the ratio between the adjacent leg to hypotenuse. Okay, so it's a ratio of adjacent leg to hypotenuse for the reference angle theta. So this is the adjacent leg because this is the leg that's next to or adjacent to the angle of reference or angle of question. Okay, so then hypotenuse is always going to be across from the right angle. The third trig ratio is tangent of theta. We read it as tangent of theta. We write it as tan theta for short. It's going to be opposite leg divided by adjacent leg. So it's the ratio of the opposite leg to the adjacent leg for the reference angle theta. So an example of using sine theta. Okay, so for 50 degrees angle, the ratio of opposite leg to the hypotenuse is 0.766. That's what we found from the decimals exercise, right? So that was because sine of theta, sine of 50 is opposite to this is this leg, 7.66 divided by 10, which is 0.766. Okay, so sine of, and then we write it as sine of 50 degrees or sine of 50 is equal to 0.766. And we read this as sine of 50 is equal to 0.766. Okay, what about cosine? Remember, cosine is the, for 50-degree angle, the ratio of the adjacent leg. That adjacent means next to the reference angle. So the leg next to the reference angle is this one. So that's for the 6.43 length over the hypotenuse. So it's going to be 6.43 divided by 10, which is 0.643. Okay, so we write this as cosine of 50 is equal to 0.643, and we read this as cosine of 50 is equal to 0.643. What about tangent? Tangent is opposite over adjacent. So for tangent of 50 is the length of opposite side divided by the length of adjacent side. So that's 7.66 divided by 6.43, which is equal to 1.191. Okay, and if you use the calculator, that's what the value that will tell you. Okay, so if I use my calculator and enter tangent and 50, tangent 50, you should get 1.191. We read this as tangent of 50 is equal to 1.191. Okay, so then right now you are going to make a copy of this document for yourself. We're going to do 20 degrees together, but you do the rest for homework. So here we go. So this document should look like this. Okay, so it looks like this. You're filling in the table and you're getting the ratios from the triangles at the bottom that is already filled out for you. So we're going to do 20 degrees triangle. So when you see the 20 degree, 20, 70, 90 degree triangle, for 20 degrees, we're going to find the hypotenuse to be 10, the opposite side, opposite leg of from 20 degrees is 3.42. So I am going to find my 20 degrees. The opposite leg is 3.42. And the hypotenuse I said was 10. And then the other adjacent leg is the one next to the 20 degrees. That's 9.39. So 9.39. Okay, so then I am looking for sine of theta. Sine of theta is opposite over hypotenuse. Opposite leg has 3.42. So 3.42 divided by 10, that's going to be 0.342 because you're just moving the decimal place one unit to the one place to the left. Okay, cosine is adjacent over hypotenuse. So adjacent over hypotenuse, so that's going to be 9.39
divided by 10, which is going to be, again, moving the decimal place one more point to the left because we're dividing by 10, becomes 0.939. Okay, so the tangent of theta, this is where you are going to have to pull out your calculator and you do that. So tangent of theta is opposite side divided by adjacent. So that's going to be 3.42 divided by 9.39. And when you use the calculator, 3.42 divided by 9.39 is going to give me 0.364. Okay, so you get your measurements from each of these triangles. Okay, so you're not going to find the 50 degree, 60, 70 degree, 80 degree triangles by looking at it just as obviously, but you're going to find, instead of down here, you're going to find 70 degrees here. Okay, so for 20 degrees, the other reference angle is 70 degrees, isn't it? Okay, so for 70 degrees, again, the hypotenuse is going to be 10, but the adjacent side is actually to the 70 degrees is 3.42. So adjacent is 3.42, and what is the opposite becomes the 9.39. And then from here, you can fill in the rest. Okay, so I am going to give you like 5 minutes during the class to do this, and the rest, whatever you do not finish, you need to complete it as homework. So now let's talk about which ratio to use. So we've learned that sine of theta is going to be opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent is opposite over adjacent. One of the acronyms that helps you to remember this ratio is SOHCAHTOA. So SOHCAHTOA says sine is opposite, that's O over hypotenuse. So this is where you get the word so. And then cosine is always going to be adjacent over hypotenuse. And that's where you get the word ka. And then toa, where you get tangent is opposite over adjacent, so you get toa. Okay, so katoa, you just say it enough times and you should be able to remember sokatoa, sokatoa, sokatoa. There are songs about it. If you Google it, there are plenty of ways to memorize this. Okay, so then let's continue. So sine of 20 degrees is 0.4342, and cosine of 20 degrees is 0.940, and tangent of 20 degrees is 0.364. That's what we figured out just by filling out the table there. So if you have a 20 degrees triangle here, okay, so reference angle of 20 degrees with right angle, that means you have to think about which is the measurement that we are given. Okay, which is the measurement that we are given here? We are given, what is this side? This is adjacent to the reference angle, and this is the hypotenuse, right? So we're dealing with adjacent of a hypotenuse, which is the ratio that is dealing with adjacent of a hypotenuse. It is cosine, right? So that would be the one that we would use. Okay, so then we would say x over 20, x over 20, so adjacent of our 20, hypotenuse is x over 20 is 0.942. And then you can solve for x by multiplying both sides by 20, and you get x is equal to some number. Okay, all right, what about this triangle? In this case, what are we dealing with? This is the 20 degrees here, reference is 20 degrees, there is opposite to 20 degrees, and this is the adjacent side. So we're dealing with opposite over adjacent, so we're dealing with tangent. And so we use x over 15 is opposite of adjacent and use that to figure out the third, the unknown side. Okay, and we'll continue with the next lesson recording.